Okay, so this is probably the most complicated type of mole calculation you can get in GCSE Chemistry. It says a mixture contains 1 kilogram of aluminium and 3 kilograms of iron oxide. The equation is given here and it says show that aluminium is the limiting reactant. So first you need to understand the difference between limiting reactant and the reactant in excess. In excess means you have more of that reactant than is needed for that reaction, whereas limited means all of that reactant gets used up. So in this question is basically saying aluminium is limiting. That means all the aluminium is going to get used up and reacted here because there is more iron oxide than is needed for this reaction. So we need to prove this. So this is the limiting reactant and this is the one that's in excess. The way to do this is to look at how many moles of each one you have, then compare the ratios in the balanced equation to see which one you have more of. And what you should find is aluminium should have less than is needed for the reaction to occur. So let me show you what I mean by this. So let's start off with aluminium first of all. To find the moles of aluminium, we use the equation moles is equal to mass over mR. Now remember, in this equation, mass needs to be measured in grams. What they've given us is kilograms. So 1 kilogram is 1,000 grams. So let's do 1,000 grams divided by the mR. In this case, we're dealing with elements, so they've given us the ARs here. Aluminium is 27. So 1,000 divided by 27. Now when you add that in your calculator, you should get 37 moles. So we have 37 moles of aluminium. Now let's look at how much iron oxide we have. What we're going to do is the same thing again. Moles is equal to mass over mR. Let's sub the values we've got in here. We've got 3 kilograms this time, so it's going to be 3,000 divided by the mR of iron oxide. Iron oxide is Fe₂O₃. We need to work that out. So Fe is 56. It's Fe₂O₃. So we need 2 lots of 56. So 2 times 56. Then Fe₂O₃. 3 lots of oxygens. So we're going to add 16 times 3 because oxygen is 16. And we're going to put that into our calculator. That will give us 18.75 moles. So just by looking at that, it looks like we have less iron oxide than aluminium. But in this reaction, what you also need to take into account is the ratio. Aluminium has a 2 in front. Fe₂O₃ doesn't have a number, which means it has a 1 in front. So in order for this reaction to occur, the aluminium has to be 2 times bigger than the iron oxide. So we've got the amount of aluminium we've actually got in the reaction, but the iron oxide needs to be 2 times greater in order to satisfy the equation. So 18.75 times by 2, that gives you 37.5 moles. So we need 37.5 moles of iron oxide to fully react the aluminium. What do we actually have? We only have 37 moles. We do not have enough aluminium to fully react the iron oxide according to the equation. Therefore, the aluminium is the limiting reactant and the iron oxide is in excess. So we can say 37.5 moles of aluminium is required to fully react the iron oxide, but there is only 37 moles. So the aluminium is the limiting reactant. And that's how you get 4 marks.